Hello everyone, welcome to Container Days 2022. Today I'm going to talk about mimicking an entire organization's GitOps control plane and a Git server onto a private cluster or a private local environment for obvious reasons. We will cover a bunch of slides on this and we will dive into some good amount of demos. And of course, if the demo codes are on our side, and I believe the demo codes will be on our side. With that, who am I? I'm Karthikeyan Govindaraj. I'm a CNCF speaker, a DevOps architect, cloud native, container native architect, and a developer. I have a deep interest in container native, cloud native experience. I develop CLIs and tools for enhancing the developer experience. I'm also an open source software enthusiast. I also blog about my technology challenges and the solutions that I have found or came across in my Medium articles. You can follow me on Twitter, Karthikeyan, where I'm active. I know this is a recorded session, so if you couldn't able to get any answer or if you are looking for some more details, feel free to follow me. Feel free to ping me on Twitter, and the conversation doesn't need to stop over here. With that, so today what I'm going to do is I'm going to introduce a little bit of terminologies, which I hope everyone is aware of, but to get the stage set up. And container native application is a software that does not just happen to work in or around containers, but rather it is purposefully designed and developed for working as a container. These containers are ephemeral, and these ephemeral as in a sense the containers can die at any given point in time, and that's the nature of the containers. So we need a proper configuration to host these containers in the proper way where we can achieve a high availability of the services. And of course, if there is no high availability of the service, then there is no need of developing a service at all, right? So with that, making an application in a container native way or a container native application will have multiple microservices embodied in it. So all of these microservices would combine or collectively make end-to-end application. So these microservices are deployed as a container, and the reason it is deployed as independent containers is to have fine-grained permissions or control over those containers. For example, to scale up and down when there is a demand or when there is no demand of any particular service in an entire application. So you might have seen a lot of examples around that, so I'm not going to dive deep into that. And when we are dealing with the multiple microservices as containers, there is a complexity of creating multiple container images, maintaining the container images, and deploying of containers, orchestrating, and the list goes on. So this is where Kubernetes kicks in. Kubernetes is one of the current leading container orchestrator that actually handles pretty much everything out of the box. And not just that, so when we wanted to use the complete features, the full set features of Kubernetes, we also need to do something like an automation around continuous integration and continuous delivery as well. So when we do that, we can actually achieve fast-paced releases. So that's where the container native stands as of today. And how can we achieve that container native in a elegant way is via GitOps. So GitOps is not a tool, not a technology. GitOps is rather an operational framework that takes the best practices from DevOps and for example, for the application development, for example, say version control systems, collaborations, compliances, CI/CD toolings, and so on. And the GitOps framework applies all those best practices onto the infrastructure and the automation and so on. So there are a few advantages of why we should use GitOps methodologies. The few advantages are say GitOps leverages a developer-centric approach, as in it leverages the tools and techniques which are developers aware of already in their work environment, say for example Git and the CI/CD workflows and so on. So that's one of the main advantage, and it is completely traceable, as in the meaning of that is everything is a single source control in a Git repository. So anything and everything that is getting deployed onto your environment is from the Git repository. So you can actually look at the Git comments, look at the Git tags and the versions and so on, and you can understand what was the historical change even without going into the release system. So that was the completely traceable part of the GitOps benefit. And the third and one of the most, I feel this is one of the most beneficial feature of GitOps methodology is recovering faster from the errors in your environment. For example, when you're deploying something from the Git repository to your environment and your environment is down, it is there are deployments that are having issues or errors. The thing you can do is with the GitOps methodology is you can actually revert to the previous commit or previous tag or whatever pointer that you used for deployment earlier to the previous one. Then you would go back to the previous stable position. So that is a kind of easy and fast in resolving the errors. And of course, it is a single source of truth. We've been talking about that over and over again. It is a single source of truth. Everything is in the Git repository, and so that it becomes easy to share these informations among the team members without any issues. So now that we saw what is GitOps and what are all the benefits of GitOps, why would someone want to mimic the GitOps control plane into their local, right? So here are the few reasons. So we saw these are configurations stored in a repository, single source of truth. So obviously it means like it is stored in a centralized repository where it is used by multiple, maybe hundreds or thousands of developers at any given point in time. So now, if I'm a new developer or if I wanted to fine tune my development strategies, be doing like multiple commits, multiple pushes, and multiple PRs onto the repository. So now what happens is like for every single repository, it doesn't cost just the build time, it also costs the infrastructure that is used for building that particular repository. And when we are following the GitOps principles, PR approval process is one of the main thing that we will be following. So which means like every single PR needs an attention from maybe one or two developers or approvers need to approve that PR, which means like they need to spend their own time to looking at your PR and then checking it and then say like, okay, it looks good and say give approval. So it consumes a lot of build time, it consumes a lot of time with the other developers, PR developers to give the approval process and goes on. So to solve these things, like what if I have a dry run environment for GitOps control plane to myself, where I could able to do this? So what if I can run a GitOps engine locally on my environment? And what if I have a dedicated Git repository instead of like pushing everything that I'm changing onto the main repository, centralized repository? What if I can push all those changes on my local, maybe a dedicated Git repository, and mimic the perfect GitOps control plane onto my local? That is the main reason essentially an entire organizations get set up in my local machine. We can do that pretty much easily. So for this, like we're gonna deploy ArgoCD, we're gonna deploy a GOG server and things like that. Of course, you can actually deploy it via using kube control directly. I developed a simple CLI where with a simple command, it bootstraps your ArgoCD and GOG server in your current cluster where your kube config is pointing. And this will actually minimize if I wanted to do too much of build push as well, I can do it. If I wanted to build it, I can do it in my local environment. If I wanted to do a PR approval process, I can actually be my own PR approver and I can actually prove that. So the cluster I used here is like Kind. It is one of the easiest local cluster to provision such an environment here in our scenario. So with that, I'm going to show you a quick little demo of like how to provision this. So what I'm going to do is I'm going to show you like what I'm having over here. So I have a kind cluster configuration, something like this, where I have an Argo cluster name, the kind cluster named as Argo cluster, and I made it as like localhost, and it is like listening. The kind cluster is listening on my 6443 port. So what I'm going to do is like I'm going to create. So I have downloaded the kind CLI already onto my local machine, obviously. Kind create cluster where config is I'm saying Argo cluster, which is going to be this particular configuration. So it's going to create a cluster on this particular configuration. So I'm going to hit enter and I have my Docker running in my local machine as well. So I'm going to create this. So it's actually going for the latest image that is 124 version of Kubernetes, and it's trying to prepare the nodes. All right, so now I have the kind cluster created and it automatically set my current kube config context to the current cluster that I have created. So for sanity check, I'm gonna do get namespaces, kube control get namespaces, I get the namespaces. So this is the current cluster. We can look through the K9s. So these are all the pods and these are all the namespaces. Of course, those are like 50 seconds and 53 seconds, like 53 seconds old, like we just created it. So now what I'm gonna do is like CNDev. So this is the CLI tool that I was talking about that I'm going to use it to bootstrap our infrastructure today. So let's see, what does cn init will do? So cn init, this initializes or deploys the ArgoCD and GOGs, the Git server in the private environment and the available flags or ArgoCD namespace to change the namespace of the ArgoCD, but I don't want to change the namespace. I'm going to let it as init. So I'm going to like, let me go to the top of this. I'm going to go with cndev init. Let's see. All right. So all of these are getting created. Let's see the namespace. Again, let me go to the top of it. Sorry about that. So I have an ArgoCD namespace and I have a GOGS namespace that are created recently. So let me see like what are all the pods in ArgoCD namespace maybe. So we got all the pods that are getting created. Similarly on the GOGs as well, I believe, right? So let's watch this on the K9 CLI and say pods probably give me all. So all of these are while getting created. So these are the pods that are getting created as of now as we speak. This actually bootstraps all our infrastructure, saying like ArgoCD and the GOGs, which is the private Git server that we want. So I'm gonna go back, and what else CNDev has is pfapps. Using this command, port forward the apps to your local machine. So let's see what does that what does it do. So this is pfapps, or okay. So I'm gonna say port forward and give me the list of apps that I can port forward. Okay, so I got like ArgoCD and Git that are deployed via CNDev. I can port forward that. Okay, port forward -f, the forward, and ArgoCD. Let's see, does it do? Okay, so do you want to continue with the default port 9091? I'm totally fine with that. So it's port forwarding. So there is a certificate issue. That is because the kind cluster have bootstrapped with its own self-signed certificate. So you gotta say trusted, and there is like when I say port forward, it came up with a username and the password. The username is like admin, and the password is also there. This is a local setup, so that's the reason like you can actually see your admin and the password, the credentials, both of them in place. So now we have this port forwarded in a separate terminal. I'm going to do the same thing for the Git repository. And the thing with Git repository, I'm going to actually say, let's say no, and I'm going to use the port 3000, for example. The thing with the Git repository, the GOG server is like you have to set it up for one time. So I'm going to choose SQLite for the setting of this server. I'm going to sign up for that. I've created an account. I'm going to log in here. All right, so I have my GOGs repository. I have my like local Git repository. I have my local application. So what am I doing now? So let me try and create a local repository, sorry, a local server's Git workflow. Now we have the GitOps control plane in our control. Now we have the Git repository in our control. Let's try this. So, all right, so now I'm going to open up a new session, new terminal, and then in my local, I have something called Helm guestbook. This is the same set of examples that you see in the ArgoCD repository. So I just took the Helm guestbook alone, and I'm going to actually make a repository, like say Argo example. So I have this. So what I'm going to do now is like I'm going to get init, and I'm just going to git checkout master, and then I'm gonna check in everything over here. Git add, git. Oh, I forgot to add the. So I'm gonna add this as my git origin, remote origin, and then I'm gonna get push. Oh, sorry, commit, and then of course I'm gonna get push. All right, so this should have gone in. All right, so it's in. So I have my little repository serving my own, served from my own Git server. So now what I'm gonna do is, if you look at this, there is a namespace creation stuff. So I'm gonna do this, but before that, this is the CNAT dev. There is one little tweak on the setting up of things. Like you actually need to change the repository URL from localhost to this one, so that the reason behind this is like your Argo CD server is like running on your Kubernetes cluster, which is in Docker locally, and so do your Git server as well. So it's easy to communicate using this instead of like resolving everything at once. So I'm just going to do this, and I'm going to create the new app. So I'm going to create a new app. So let's do that. So the application name is like, since this is like local in cluster guest book, before that in cluster namespace creation, for example, TION. And let's do it in the same project, default project, and the source is something like this, followed by, sorry, followed by this one. So I'm just gonna take out that localhost path, and then I have something like this. Branches is head, and path is like, I'm gonna say, because that's where the namespace is, and this is like okay. So I'm just gonna do the creation. This is gonna be out of sync because I did manual, so I'm just gonna do manual sync. So now I have the namespaces there. So for example, if I go and get a namespace list of namespaces in the current cluster, I would actually see a guestbook namespace that got created. So and like a proof of that that is getting deployed via ArgoCD is like something you will actually see. This is the Kubernetes kube control configuration because ArgoCD uses kube control. So now this is in there. Now what I'm going to do is like I'm going to do the same thing, like application name is like in cluster. So that was the creation of the namespace. We haven't actually created the application yet. So I'm going to do an application creation here. This guy minus the local host. So I will copy this guy. And then path is, so now this time we're going to just deploy that one, the exact application, and the namespace is guestbook is the namespace that we want to deploy. And of course the values file, we want to say values.yaml, and everything should be peachy. Now we should actually look at the in-cluster application that's getting deployed in its own namespaces. You get a service, you get a deployment, corresponding endpoint slices, replica set, and the pod. So now if we go back to this, kube control get pods in the guestbook namespace, we will see the pods getting created, or maybe let's do all. We will see all the objects that are getting created, like say pods, replica set, services, deployments, and etc. So this is an in-cluster configuration. So we did this. So now what we also wanted to do is like, let's go back to a slide for a bit. So that was that infrastructure provisioning that we did. So now the mimicking GitOps workflow is what we did. Like that was one of the type of usage. The other type of usage is like we can also mimic the multi-cluster deployment in the scenario. So we can use the same GitOps control plane. So of course, like GitOps control plane can target to multiple Kubernetes clusters or multiple environments. So we can use our local environment to do the same as well. We can create multiple Kubernetes cluster, we can add that, and we can do that. So we're going to use the same kind cluster here, like kind as in like Kubernetes and Docker approach. And using that, we will use the same ArgoCD setup or adding the target cluster as well. So now we saw the single cluster demo. Now we're going to look at the multi-cluster demo. I actually have another kind configuration. So this is the kind remote cluster configuration where this will be the remote cluster for the current GitOps control plane, the ArgoCD that we are running. The catch here is like you actually need to set the API listening server address as your local machine IP address so that like ArgoCD can actually talk to the remote cluster and the port number of whatever the port number that your cluster want to listen on. So I'm going to apply this configuration to create the secondary kind cluster. So this will create a cluster with that particular IP address, and it will listen on the IP address that we gave, the port number that we gave over here. And again, to reiterate, the secondary cluster or the clusters that you wanted to create after the first cluster where the ArgoCD needs to connect to must be on your local IP address, and only then your ArgoCD can able to talk to it easily. All right, so we got our secondary Kubernetes cluster, which we're going to use as a remote cluster for our ArgoCD. So now kind of itself, like it created kubeconfig and set my current default kubeconfig as this. So I'm going to check by doing a simple kube control get namespace. I get the namespaces. So what I'm going to do now is I'm going to check if I can add ArgoCD. Before that, what I need to do is like I need to actually log in to my local ArgoCD CLI. You need to have an ArgoCD CLI as well. So what I'm going to do is like I need to log into ArgoCD, and but the thing is like ArgoCD is like running on the first cluster, so I need to actually go back to the first context, and then I need to actually do ArgoCD login to the address that I actually have is localhost 1991 with the username as admin and password as, oops, not that, the password as this guy. So again, that's the certificate issue. So ArgoCD is updated. So if I actually say list on this particular ArgoCD, we should be able to see like a couple of that, which is also synced and healthy. All right, now let's move to the secondary remote cluster that we created on our kubeconfig. So now let's see ArgoCD add um, ArgoCD cluster add. So ArgoCD cluster add name remote cluster, and it's gonna be kind remote cluster. So now this will actually try to add that. There is one little problem. The version of the kind that I'm using is like 124, and there is a problem in creation of the service account. So what I'm gonna do, so it's gonna error out. I'm gonna leave it to error out. But meanwhile, what I'm gonna show you is like, so this is the remote hack that we have. So we need to create a secret. I'm just gonna create this, which has this corresponding annotation. That's pretty much it. In the kube system namespace, of course. I'm just going to wait for it to error out. Now it's errored out. So I'm going to create the secret that I showed you, which is nothing but the annotation is the most important thing, like which has Kubernetes IO, service account name is ArgoCD manager. So with that, I've created that secret, and actually in the namespace, you should actually get a service account called ArgoCD manager, which was the resultant of this particular thing. And what I'm going to do is like, so this doesn't have the account secret token attached to that, which is very mandatory. So I'm going to manually do that by patching that using the kubectl patch command over here. So this should patch it. So now if we see that, it should also have the token as the secret there. So now again, if I run ArgoCD cluster add command, it should automatically add the cluster to our local one. So now this is in place. Now I'm gonna go back again to the previous cluster, which is a primary cluster, and see ArgoCD cluster list. So when I do ArgoCD cluster list, now I should be able to see both of the clusters, like the primary cluster, which is in cluster, and the secondary, the remote cluster that we have created. And it is not monitored because by default, ArgoCD doesn't monitor a cluster if it doesn't have anything to deploy onto that cluster. So now what we're gonna do is like, we're gonna do the same process of creating a namespace and deploying the application, but this time we're gonna do it through the remote cluster. I mean, in this case, it is running on the same machine though, but it is a remote cluster up away from our ArgoCD component. So I'm gonna do like say remote namespace, the same processes, remote namespace, and the repository URL is also gonna be the same. Come on, this one minus the localhost port, and the path is namespace. And so now we need to choose the cluster URL. So this is a cluster URL. So that's what the remote cluster is. I'm going to choose that, and it's not a namespace. It's a namespace, so we cannot actually provide a namespace over there. So I said yes, and oh wait, hold on. Namespaces is the repository location. Right. So now we got the namespace as well created over there. We can actually validate that using the context over here. So kubectl get namespace. On this context, you will see a guestbook namespace just got created 12 seconds before. So now we got to do the same remote guestbook application and do an automatic sync. And I should have copied the URL probably. The repository URL and the path is, since we're going to deploy the chart. So this is the cluster URL, and the namespace is the guestbook. And of course, use a values.yaml and just create it. So now you will see that is actually getting created, and that is actually getting created onto the secondary cluster that we got deployed. So now we can actually verify that using all in this particular remote cluster context. Wait, not box, it's just guestbook. So all of these are getting created as we speak. Just give me the pods to see, and let's wait for the pod to get up and running. Come on. Okay, so there we go. So we can see all of that. We can see a pod, service, a deployment, and everything is up and running. So this is it. And the thing is, like, if you go to the Kubernetes clusters and you can see this over here, you will actually see this. So now, the other thing is, like, you can also create projects, and you can create labels and things that you wanted to do over here with ArgoCD. So that concludes our single cluster deployment and ArgoCD workflow methodologies and the multi-cluster approach. With that, thank you so much for watching this session. And if you have any questions, please feel free to follow me or ping me over Twitter. And there's a QR code for my profile, which has links to everything, like my Medium article, my GitHub profile, and everything as such.